One of the most surprising parts of my job as an SAT tutor isn't solving the problems, it's understanding the student's psychology. It doesn't matter how bright or gifted you are human, and as a human, you are subjected to biases. These subtle errors in judgment can have a huge impact on your SAT score and on your chances of success more broadly. So in this video, I'm going to walk you through 5 quiet but powerful psychological biases that might be sabotaging your prep and wrecking your test day performance. And more importantly, I'm going to tell you how to overcome them. Up first is what I call motivated exit bias. In short, you see something unfamiliar or confusing in a problem, and you use that feature as an excuse to give up too early. I see this all the time working with students one-on-one. Maybe the word constant makes you uncomfortable, or you're not sure what to do with the condition n must be greater than 0, or maybe you see a physics formula and assume the question's out of reach because you've already dropped physics. In my experience, you will often be fully capable of solving these sorts of questions without knowing the thing you think you need to know. But once you've labeled that unknown element as critical, it becomes a perfect excuse to exit prematurely. So, motivated exit bias. It's a term I came up with, so it's academically a bit questionable, but the behavior is very real and sits pretty comfortably at the intersection of 2 well-documented biases: motivated reasoning, which is the broader human tendency to favor conclusions that protect our feelings over ones supported by evidence, and attribution bias, the tendency to blame external factors rather than internal ones for our own personal failures. Say you see a problem about force, mass, and acceleration, but you're not a student of physics. That formula might make you uncomfortable, and that discomfort might easily push you to find an excuse that protects your ego, like, I don't take physics, so I can't solve the problem. That's motivated reasoning. You're also choosing to blame circumstances out of your control. In other words, it's not your fault that you don't take physics. Why is there physics on the SAT? That's so unfair. That's attribution bias, blaming the world for your own failure to address the question at hand. Now, here's the thing. If you'd paused and read the question carefully, you might have noticed that the formula is given to you. Your only job is to punch in the numbers. But what you saw made you uncomfortable, so you quit before actually reading the information given to you in black and white. If you want to be a resilient problem solver, you must learn to lean into that discomfort. Exploring multiple approaches to problems, failing repeatedly, and keeping careful track of your past mistakes are all invaluable parts of mastering any topic or skill. Of course, during the real test, you won't have time to fail and fail again as you figure out the mechanics of a math problem. But if you have done the hard work, when test day comes around, you will make considerably better time management decisions when it really counts. Which brings us to the next cognitive bias. The easiest way to ruin your entire SAT is by mismanaging your time. Assuming you're a normal human, at some point you've probably spent way too much time on a question you didn't really know how to solve. And the more time you spent, the harder it became to let go. Like, I've already spent 2 minutes on this question, so now I've gotta finish it, because if I don't, I've just wasted 2 whole minutes and gotten precisely nothing out of it. Right? Wrong. This type of thinking is a classic example of the sunk cost fallacy. And this one is a real term from economics and psychology that refers to the tendency to stick with something just because you've already invested a bunch of resources, in this case time, even when continuing to invest more resources, so more time, is clearly a bad idea. When you've already poured energy into a problem, walking away feels like failure. You've committed effort and attention, and your brain wants closure. It wants a payoff. It wants that sunk cost to mean something. Letting go can feel like admitting defeat, and that's exactly why it's so difficult to do. But here's the thing. What came before doesn't matter. That time is gone. All that matters now is what you do next. So when you're in the thick of it, ask yourself, is this the best use of my next 30 seconds? Or is my time better spent on another question? And the truth is, after you've spent 3 minutes on a problem fumbling around, you probably won't get it right even if you take another 10. In fact, your odds of getting the right answer are probably dropping with each passing second, and you are almost certainly going to get the problem wrong anyway. Not always, but in the vast majority of cases. And even if you do get it right after spending 5 minutes punching away at it, those 5 minutes could have been spent on anywhere between 3 to 5 questions that you do understand. Questions that might be easier, more familiar, or just faster. Or it could have been used to double-check previous work and catch simple mistakes on questions you actually do know how to solve. Either way, that time is almost always better spent elsewhere. The key to breaking the cycle, then, is to reframe your decision. Choosing to let go isn't an admission of failure, it's an investment strategy. If the next 30 seconds won't increase your odds of getting the question right, just move on to the next question. Which isn't to say you should always give up. Okay, this next one occurs when you do actually have a clear, guaranteed method, but you abandon the question because your method just feels too long or tedious. Under pressure, your sympathetic nervous system is on high alert. Your heart rate goes up, your knee might start bouncing, and just visualizing a long process can spike your stress even more. And that stress can make it really hard to stay put and work methodically. Oddly enough, in my experience, the clearer your steps are, the slower they tend to feel, like mopping the floor or doing the dishes. A multi-step solution to a problem will feel like a chore, and chores always feel like they take forever. So you skip the question, hoping the next one will be quicker. But here's the thing, that slow method may not actually be that slow. If you simply start working calmly, methodically, you'll often find yourself at the answer before you even know it. A question that takes 75 seconds might feel excruciating in the moment, but 75 seconds is a perfectly reasonable amount of time to spend on an SAT question. Even spending 2 to 3 minutes can be completely justifiable if you're confident in your path and likely to get the question right. In a test full of uncertainty, that kind of certainty is gold. Here's the gist of it. If you know how to solve it and you're unlikely to make a mistake, it is a good use of your time. If you don't have a plan, even a fast problem can turn into a time sink. So just to be clear, skipping a problem isn't always a bad move, as long as you're not skipping it in favor of one where you don't have a plan. And if you do skip it, you must circle back. There's almost always a question on the test that you don't fully understand and shouldn't spend time on at all. This isn't that question. That's why I usually recommend just doing it. Once you've processed the problem and you know what to do, don't stall. Don't stack up decision fatigue by switching back and forth. Just breathe in, exhale slowly, and get to work. Okay, number 4 is what I call continuity bias. It's my own term for a mistake that I see students make constantly in SAT math. It's closely related to the psychological concept of normalcy bias, which is the tendency to assume everything is fine even when subtle warning signs suggest otherwise. In math, this shows up when you make a small mistake, like a sign error, a dropped square, an undistributed negative, and then you hit something weird a few steps later that kind of makes you stop for a split second and go, huh? But instead of stopping to investigate the source of the feeling, you brush it off and you push forward. Probably fine, right? But your subconscious mind is a pretty amazing thing. And that feeling you got that gave you pause, that was your mind raising a red flag because something is off. One key brain region involved in this process of error detection is the anterior cingulate cortex, or ACC. So when you get that subconscious inkling that something's gone awry, that's your ACC raising a red flag to let you know that something in your environment has violated your expectations. Once that red flag is raised, areas like the dorsolateral prefrontal cortex, or DLPFC for short, decide whether to act on that signal. So either you'll pause and try to resolve the conflict, or you'll ignore it and press on. But under cognitive strain, like when you're juggling multiple steps, running out of time, or mentally fatigued, your brain can become less responsive to those signals. The red flag goes up, but nothing happens, and the mistake keeps moving forward. Those tiny flickers of doubt, they matter, and you can train yourself to recognize them. When something feels off, when your gut says, wait, what? Don't ignore it. Instead, build a habit of pausing. Even just 10 seconds to scan your last step, check a sign, or trace a variable can save you from following a wrong path all the way to a wrong answer. So, when something feels weird, pause. That discomfort is a signal, not a distraction. You don't have to catch every mistake in real time, but building a habit of responding to internal friction is one of the most powerful tools you can develop during practice. Because on test day, your best safety net is your own awareness. Okay, so the last bias we're going to cover today is what I call canonical form bias. This is the tendency to default to equations with the variable on the left-hand side, like x equals 3, even when isolating x by placing it on the right-hand side would be far more effective. Canonical form bias is again my own name for this tendency, but it is a great example of two well-documented forces from psychology. For one, the mere exposure effect, which is that we tend to prefer formats we see most often. So in this case, we've seen x equals something like over and over and over again in math class, so that looks safer. It looks more familiar than the form something equals x. And the second is the framing effect, which is all about how information is framed or presented. So if a math problem is presented in a certain way, like 10 minus x equals 7 versus 7 equals 10 minus x, that tiny difference may completely change how you approach the problem. Of course, both equations are trivial, but many students find the first slightly harder because they instinctively keep x on the left, which means that the x stays negative. Now, to make x positive, they have to multiply by -1. But if instead you move x to the right, the work is slightly cleaner. Okay, fine. We get 3 equals x, which looks unfamiliar and a little ugly, but it's absolutely fine. Okay, now I know what you're thinking. What's the big deal, right? Well, have a look at this more realistic example. If your goal is to isolate x, the cleanest path is to keep x on the right so that it stays positive throughout the process. That's direct. No negatives, no extra steps. All right, so now let's compare it to the other approach and move x to the left. And now watch what happens. So we got the same answer, but the route was a little longer, a whole lot messier, and full of negatives. And if you're being honest, did you understand every step perfectly, or were there some steps that gave you pause? And here's the really critical part. A disproportionate number of equations on the SAT are designed like the one above. If you insist on placing x on the left, you'll wind up in a real mess. So if you're uncomfortable placing the unknown variable on the right, you will suffer. I promise you. Now, I can't be sure that the College Board does this on purpose, but the pattern is so common, it's hard to imagine that this is a coincidence. So remember, when you solve an equation, try to visualize which path will produce fewer negatives, and stick to that, regardless of what you're used to seeing in math textbooks. So here's a quick recap of what we've covered. Number 1, motivated exit bias. Don't quit early just because you're uncomfortable with the word or phrase. Number 2, the sunk cost trap. What came before doesn't matter. Ask yourself instead, what can I achieve in the next 30 seconds? Number 3, the slow path fallacy. If you have a clean, reliable method, stick with it. It is worth your time. Number 4 is continuity bias. Pause when something feels off. Your ACC is trying to tell you something. Number 5, canonical form bias. Let the variable live where the algebra is easiest. Master these and you will quickly become a faster, stronger, and far more intuitive problem solver, not just in the SAT, but in any project or personal challenge you face in the future.